guys. So today I want to take a comprehensive explanation of calculus. I will start it step by step. This is a full series that I will be teaching. So take your pen, take your book, and whatever you have not understand, we'll reveal that mystery now. All right. So we have calculus. Calculus, as the name implies. So in calculus, we have two subtopics here, and the first one is differentiation. Differentiation. So in differentiation, from elementary, I don't want to bring about limit here, but I will start from Roman figure 1. I will start from first principle. First principle. So for first principle, we have two formulas that we'll be using to solve problems in differentiation from first principle. So the first one here, we have a formula y is equals to del y is equals to open bracket x plus del x, close the bracket. So in this one, we can be using the formula to solve problems in differentiation. And the next one, the second one, is f of x, then is equals to f of bracket x plus h in bracket minus f of x, close the bracket, all over h, as the h tends to, h is the limit, just as this one also is the limit from the first one. So as h tends to 0, we can determine the derivative of any function. So let's take an example. We are to solve x squared plus 3x. Let me start with this one. X squared, we are to differentiate y with respect to x. And in this case here, we have it to be y equals to x squared. Now, in this case, whenever you see something like this or like this, this implies f of x is the same thing as y. Then x, the increment of x, is same thing as x plus del x. So by this one, if we are using the first formula, we will have this to be y plus delta y is equals to, so because of this is the increment of x for every x here, so this will give us the same thing as open bracket x plus del x all square. Then this one here will be plus 3 open bracket x plus del x. So you can see, because of x square, we bring the increment here, we square it, then x, we bring it here. So this will be del y, we take this to the other side, it will be equal to opening this bracket, this square will give us x square, this, it will give us plus 2x del x. And then you square this, it will give us plus del x square, then plus 3 open bracket x plus del x, close the bracket, minus y. So let me take this one up. Taking this one up, we'll have del y is equals to, we have this x square, and then plus 2 del x plus del x square. And then when you multiply this one, you have plus 3x plus 3 del x, and then minus our y there. Y is equals to x squared plus 3x. So this will give us open bracket 3x plus, open bracket x squared plus 3x, close the bracket. So by implication, since y is equals to this and is carrying minus, so by the time that we multiply all of this, it will give us minus x squared minus 3x. So that will give us, when we open the bracket, so by implication, this will cancel this. This also will go with this. We are left with del y is equals to 2 del x. I think there's something I didn't put there. It's supposed to be x del x plus del x square, and then plus 3 del x. In this place, when you reach this step there, what we will do here is to divide all through. Divide all through by del x. So when we divide all through by del x, it will be del y all over del x is equals to this divided by del x will give us 2x. This divided by del x, then definitely it will leave us with del x. This divided by del x will give us what? Will give us 3. So when we get this one, what will happen is this. We will now have del y all over del x is equals to as del x, sorry, as del x tends to 0, then del y all over del x tends to dy all over dx. So by implication, dy over dx from this will be equals to 2x plus 0, then plus 3. Finally, our answer will be 2x plus 3. So this is how we solve problems in the first principle. I will take another example, but the example that I will take, it has to do with a fractional example. Thank you so much for watching, and please subscribe if you are coming for the first time. Alright, so here I want us to solve another problem in this subtopic, but it has to do with a fraction. So assuming that we have y is equals to 1 all over x raised to the power of 3. This one is a long one, but it is good to solve the complex one so that when you understand this, you can be able to tackle the simpler ones. So we'll solve this particular differential equation using first principle. So I would like us to go this way. Here, the formula is del y is equals to del x in bracket minus y. I just took the y there so that we can go without multiplying steps. So this is del y is equals to 1 all over x plus del x, and then all raised to the power of 3 minus 1 all over x raised to the power of 3. So since y equals to this, so we replace it there. But this is the increment of x, so we put it at the denominator as the increment when we cube it. So now for us to do this one, recall from Pascal triangle, when you have one, when you have a power of 0, you have this. When you have power of 2, you have this, the coefficients. But when you have the power of, the next one will be 1, and then we have 2, and then we have 1. This is when the power is 0, when the power is linear, when the power is 2, then when the power is 3, as in this case, this will be 1, 3, 3, 1. So by implication, let's open this bracket here. Let's open this particular bracket. What I will do first of all is that we'll have delta y is equals to, so this one here will give us the same thing as x raised to the power of 3, and then plus 3, because this one here, x raised to the power of 2, and then delta x, then, I think it's supposed to be 1 all over, then the next one will be plus another 3, then we have x, then delta x square. Finally, we'll have this one to be delta x square, cube. If you check what's happening here, the value of this one, x, is reducing while the value of delta x is increasing. So that's how you find this without putting much steps on this one. So we now have this one minus 1 all over x raised to the power of 3. So having gotten this one, okay, I think I shouldn't have even suffered us to this. Please, let me not take it this way. Let me kick out this one, so that we don't necessarily need to open that bracket. Let's take this one here. Is delta y is equals to, this time this is x cubed, this time this, so it will be plus x raised to the power of x plus delta x all raised to the power of 3. Then this time this will give us x raised to the power of 3 in bracket x plus delta x plus raised to the power of what? 3. So by implication, this is delta y equals to that bracket supposed to be open here. Then x cubed, then plus, I've already opened it, so it's x cubed plus 3x square delta x, and then plus 3x delta x square, and then plus delta x cubed all over x cubed divided by x plus delta x in bracket raised to the power of 3. So by implication, when we have this, sorry, this is supposed to be, this is minus. So this is minus here. So this one here is minus. Here also it will alter it minus. It will alter this one to be minus. It will alter this one to also be what? To be minus. So having gotten this one, you see that this will kick out this one. We are left with delta y is equals to, you check this one here, delta x is common, so we have minus delta x, and then in bracket 3x square, and then this will be the same thing as plus 3x, and then this is plus, sorry, yes, plus delta x square, close the bracket, all over, this will be delta x. So if you check here, we have delta x raised to the power of 3 in bracket x plus delta x, and then close the bracket cube. So having gotten this one, the next thing that we'll do in these steps always, you divide all through by delta x. Let's take it up. So we divide both sides, the left hand side and the right hand side, by del x. So this will be del y all over del x is equals to, when you divide here by del x, definitely this will be kicked out. So we are left with minus open bracket 3x square, and then we have plus 3x, and then we have plus delta x cube, close the bracket, sorry, x square, close the bracket, all over x cube in bracket x plus delta x all raised to the power of 3. So having gotten this one here, we will now draw the conclusion to find our answer. As delta x tends to 0, by implication, delta y all over delta x tends to dy all over dx. So by implication on this will give us dy all over dx is equals to minus open bracket 3x square, and then plus 3x, then plus open bracket 0 square, close the bracket, all over x raised to the power of 3 bracket x, and then this will be 0, close the bracket, raised to the power of 3, close the bracket, raised to the power of 3. So this will be the same thing as minus bracket 3x square plus 3x, then and then plus 0, close the bracket, all over x raised to the power of 3 in bracket x raised to the power of 3, x raised to the power of 3. Finally, here we will have this. Since there is x that is common here, we'll factor it, minus x in bracket. Then we have this to be what? We have, no, okay, let me leave it this way, sorry. So this one will be minus 3x square minus 3x all over x raised to the power of this plus this. Since it will be all over 6. So we factor out x. When we factor out x here, then we'll have this one to be minus 3x minus 3 all over x raised to the power of 5 as our final answer. So this is how you solve when it has to do with fraction of when it has to do with fraction when you're dealing with first principle. So I won't dwell here much. We'll take other example, but in this one we'll migrate to the general form of differential equation. Alright, so the next one is the general form. The general form, which will be able to solve problem, will be able to make it more easier than the other one. The general form, say you have a function y equals to x raised to the power of n, where n is any integer. You can assume any value from 0 or from minus f to any kind of number. So in this one here, when you have to differentiate this difference, in this case, is either dy dx. This is called a gradient. This is also the same thing as y prime. This is also the same thing as f of x prime. So in this situation here, when we have this, in this case, I will use y prime. Y prime means dy dx, which is the same thing as you bring this end down, and then the end, you will reduce it by 1. So this is the general form of differentiation. If you don't understand the first one that I dealt with, this is what I was actually using, solving in this, guys. So here we will have this one. Let's take the example previously. Remember, the first question was y is equals to x square plus 2x, y square plus 3x. So this was the first question. And in this question, let's assume that dy over dx, we are using this formula now. So you bring the power down, which is 2x 2 raised to minus 1, and then plus 1 times 3x raised to the power of 1 minus 1, because the power here is 1. So by implication, this will be 2x, 1, this will be 1, and then plus 3x raised to the power of 0. Anything raised to the power of 0 is 1. So our answer is 2x plus 3. You can see this one. It doesn't have, we don't need to solve it the way we did the previous one. This one is just straightforward. So I would like to solve the other one also. The other example, y is equals to 1 all over x raised to the power of 3. The one we just finished using first principle. So let's solve this one here. This one, I can express it, since this one is an exponential form, this is the same thing as x raised to the power of 3. So since this one is the same thing as x raised to the power of 3, let's see. Yes, so this will be the same thing as what? This will be the same thing as dy over dx is the same thing as, you bring this one down, so this will give us the same thing as what? To give us the same thing as minus 3x raised to the power of minus 3x raised to the power of minus 3 minus 1. So that this will give us minus 3x raised to the power of minus 4, which is the same thing as minus 1 all over x raised to the power of 3. So you can write it like this. So if you remember from the previous one, there was a mistake I made there in terms of calculating the del x. So we are supposed to have this answer, but there's something I didn't cancel very well, and I included it. So we will make correction of that. Thank you so much. Okay, all right. So let's proceed with the general form. With the general form, let's assume that since let's have a polynomial y is equals to, this is x raised to the power of 3 plus 3x raised to the power of 2 minus 6. So let's say we have a question like this, which is one of the simplest form of differentiating y with respect to x using the general form. So here y prime is equals to, you bring this one down, this is 3x, you reduce it by 1, this is 2, and then plus, you bring this one down, this is 6x, and then you reduce it by 1, then minus, when you differentiate, the constant is 0. So our answer is 3x squared plus 6x. So that's how you actually manipulate when it comes to general form. But the question is that, what of if you are given a question that you have y is equals to, since it is differentiation, let's say we have a question like 1 minus 3x raised to the power of 2 in bracket raised to the power of 3. So what about if I have a question like this? It's becoming complex. So by that, it will be we can solve it directly using the general method, but we have another formula that we can use. So that leads us to a subtopic called a function of a function. So here, function of a function. So for function of a function, we have the formula here, dy all over dx is equals to dy all over du times du all over dx. So in this case, we have introduced another variable here, u. So since we have introduced a variable u here, what will happen here by implication is that, now let's say we have this example, y is equals to 1 minus 3x square close bracket raised to the power of 3. So this will say let u be equals to what is inside the bracket, which will be 1 minus 3x square. Then by implication, our y now is equals to u raised to the power of 3. So this place is u, which is this, and then y is equals to u to the power of this one. So we can solve this one here. We'll say du all over dx. That is when we differentiate u with respect to x here. When you differentiate the constant 1 is 0. But when you differentiate 3 minus 3x raised to the power of 2, it will give us minus 6x, because you are bringing this one and multiply here, which will give us the same thing as minus 6x. And then we will take this one. For the next one is dy all over du. We are differentiating y with respect to u here. So this will give us the same thing as 3u raised to the power of 2. Why? You bring this one down, you reduce this one by 1. So that's why we have 3u raised to the power of 2. So having gotten this, we can now substitute it in the formula to find the derivative of x. So this will be dy all over dx is equals to our dy du is this one. So this will be 3u raised to the power of 2 times our du dx is this, is this one. So this is minus 6x. So we multiply this one, which will give us the same thing as 6 times this will give us 18. And then we have x u raised to the power of 2. So finally, this will be minus 18x in bracket. Our u is given to be this. So this is 1 minus 3x square, close the bracket, raised to the power of 2. So this is how we solve problems using a function of a function on this one. You can decide to solve direct method. Actually, for those writing exams, there is a method that I usually use to solve this one, which is if you have y is equals to open bracket 1 minus 3x square, close bracket, raised to the power of 3, then this one dy all over dx is equals to, you bring this 3 down and then multiply by, you differentiate what is inside. You remember when we differentiated this one, which is inside, the answer was minus 6. So here is minus 6x in bracket. You bring the 1 minus 3x square, then this is 3, you reduce it by 1. So by implication, this time this will give us minus 18x in bracket 1 minus 3x square, close the bracket, raised to the power of 2. So you see this one. Instead of doing this long journey, you have it just 3 steps as your own answer. So you can use this one whenever you have exam that requires the time bound. You can apply this one. Thank you so much. Make sure if you are coming for the first time, like, subscribe, and also comment. Thank you. So, I will not, there are many questions on this. I won't take much question. Let's move to, what about, we will be solving problem on this particular one when we go to, when we get to logarithmic functions, exponential functions, and trigonometry functions. So in that one, we will be using such. So here, let's assume that the next subtopic is product rule. And in product rule, what about if you have a derivative of ay is equals to ax plus 3 in ax plus b in bracket cx square plus d? If you have something like this, how do we resolve it? The formula is, sometimes we have it as y equals to uv. So this will give us dy all over dx is equals to u dv over dx plus v du all over dx. So in this case here, when you have a function in this form that are multiplying each other, we'll be dealing much of this one in integration. The integration aspect of this is called the integration by part. So we'll deal with that one when we got there. So so here, what will happen here is this. Assuming that you have a question, y is equals to 3x square minus 1 in bracket, another bracket. So this one will be x plus 3 raised to the power of 3. So when you have a question like this and you are asked to find the derivative of y with respect to x, so what will happen is this. We'll say let u be equals to the first one, 3x square minus 1, and v will be equals to x plus 3 in bracket raised to the power of 3. So by implication here, you differentiate each one of them. That is, we have du all over dx, differentiating u here with respect to x. You remember, when you differentiate, the constant is 0. When you differentiate 3x squared, you bring this one down, which will give us 6x. You reduce it by 1. So the same thing again, dv all over dx. I will apply the previous example. What I did, you bring this one down, 3. You differentiate what is inside. Differentiate 3 is 0. Differentiate x is 1. 1 times 3 is 3. So this will give us x plus 3 in bracket raised to power. Reduce this one, it will give us 2. So we can now go back and substitute it in this formula. That is, dy all over dx is equals to u. This is our u. Then this is 3x squared minus 1. Close the bracket. Times dv dx. dv dx, this was the answer. 3 open bracket x plus 3 close the bracket raised to power of 2. Then plus, we'll take v. V is equals to this, which is x plus 3 in brackets raised to power of 3 times, then du dx. Du dx is what? Is 6x. So we can now simplify this one by factorization, because if we had to expand this one, to make it more complex, so the best thing to do is to what? Is to factor it out. So to factor this one out, it will give us the same thing as, you see, this one is common. Since it has square, then we'll factor x raised to x plus 3 in bracket raised to power of 2 open bracket. We are left here with 3 open bracket 3x square minus 1 close the bracket, and then here we are left with plus 6x in bracket x plus 3 close the bracket, so that by the time that you multiply this with this, you will have this. You multiply this with this, you will have this. So that's the reason why we factor it, so that to make the simplification simple. So we go up, we'll have dy over dx is equals to, let's expand the bracket inside. This will be x plus 3 in bracket square, and then we have this times this will give us 9x squared minus this time this will give us minus 3. This time this will give us plus 6x squared, and then this time this will give us plus 18x, close the bracket. So this will give us x plus 3 in bracket raised to power of 2, another bracket. This plus this will give us the same thing as 15x, yes, 15x squared, and then we have plus 18x minus 3, close the bracket. You can decide to expand this one, but I will always leave it in this way to avoid the complex expansion, which is still the same thing. Thank you so much. So this is how we solve problems when you have things that has to do with product rule. I will still solve problems more on this, but because I don't want to make the video to be too long, we will move to the next subtopic, which is whenever you have a question that has to do with division, how do we tackle that one? Alright, the one of division is called the quotient rule. The quotient rule. And for quotient rule, imagine you are given a question y is equals to u divided by v. So this is a quotient. We cannot treat it the way when it is a function of a function, or when it happens to be a product rule. So in this case, we have an established formula, which is, this one is dy all over dx is equals to v du over dx minus u dv all over dx, then all over v squared. So this is the formula. Now, I want you to be very careful here. When I took you product rule, when arranging this one, when arranging this particular one, you recall that we can, this is, if it is plus, you can interchange this one, because addition is commutative in nature, but subtraction is not commutative. So as a result of that, we cannot be able to interchange. This will always come first before this one. So to solve a problem, let's assume that we have y is equals to x squared minus 4 all over 3x plus 2. So assuming that you have a question like this, there's a way we can do it direct, but I prefer us elementarily we use the formula, because it will be easier for us. So in this case, to find dy dx here, we will let u be equals to x squared minus 4, and then v will give us the same thing as 3x plus 2. So in this case, du all over dx is equals to, when you differentiate this is 0, differentiate this is 2x, comma, and then differentiate this one with respect to x. When you differentiate this is 0, differentiate this one to give us 3. So we can now go and substitute in the formula, which will have dy all over dx is equals to v is this one. So this is 3x plus 2 in bracket times du dx. Du dx is 2x minus, then the next one is u. U is x squared minus 4 in bracket times dv dx is 3 all over dv is 3x plus 2 all in bracket square. So having done this substitution, we can now simplify either by opening this bracket, since there is no much to factor out. So here, this time this dy over dx will give us the same thing as, this will be 6x squared, that is, this time this is 6x squared, this time this will give us plus 4x minus, this time this will give us minus 3x squared, and then minus time minus is plus, this time this will give us 12. So this will give us plus 12 all over 3x plus 2 all in bracket raised to the power of 2. So this is the same thing as this minus this will give us 3x squared, and then we have a quadratic equation there, which is plus 12 all over 3x plus 2 all raised to the power of 2. So this is how we solve this one. There are cases that we will be asked to find the derivative of this at a point x comma y is equals to open bracket 0 comma or minus 1. So in case of this, it means that dy all over dx at this point, when x is equals to 0 and then y is equals to minus 1, this will give us the same thing as, we have 3 open bracket 0 square plus 4 in bracket 0, and then plus 12 all over 3x plus 3 times 0, and then plus 2 all bracket square. So by implication, this will give us 0, this will give us 0, then we are left with 12 all over, this will give us 0, this will give us 2. 2 square is what? 4. Our answer will be what? Our answer will be 3. So there are times that we can be asked to find a derivative of the gradient of a function at a point. So in this case, the gradient is what? Is 3. So this is how we solve problems when it comes to differentiation using a quotient or a function that has numerator and a denominator. So because of the complexity of this, I would like to take another example before we proceed. So let's say we have y is equals to, we have x raised to the power of 3 minus 2x all over, then we have 2x squared minus 1. So let's say we have a question like this and we are asked to find the derivative of this. So to find the derivative of this, I won't use the formula, I will use the direct method. So the direct method here is that dy all over dx will differentiate up and leave down. So this is 2x squared minus 1, which is what we left, and then we are differentiating this one. When you differentiate this, differentiate 2x is 2, differentiate x raised to the power of 3, it will be 3x squared and then minus 2. Then minus, we are now leaving this one, we'll differentiate this, which is the same thing as x raised to the power of 3 and then minus 2x in bracket times, differentiate this one is 0, differentiate this one, it will give us 4x all over 2x squared minus 1 all in bracket what? Square. So this is how you differentiate it using the direct method, which will not cost you much time. So here, this will be equals to, this times this is 6x raised to the power of 4. Let me expand the bracket, since there's nothing to factor out. Okay, let's see. All right, no, there's nothing to factor out. So this again time this will give us minus 3x square. Then this time this will give us minus 4x square. And then finally this time this will give us plus 2. Then this time this will give us minus 4x raised to the power of 4. And then this time this minus minus will be plus, so that we are left with 8x square all over 2x square minus 1 all in bracket square. So in this case here, this will be the same thing as 6 minus 4. That will give us 2x raised to the power of 4. And then minus this minus 7. Minus 7 plus 8 will give us definitely plus x raised to the power of 2. And then we have the constant, which is plus 2 all over 2x square minus 1 all raised to the power of 2. So this is how we solve problems that has to do with this form. Okay, so this is how we solve this one. So make sure if you are coming for the first time, you also share and comment. So what we'll do here is this. In differentiation, it covers different aspects. We can deal with when we have logarithmic function, when we have trigonometry functions, and also when we have functions that are exponential in nature. How do we solve problems like that? So let's dive into that one after the other. Okay, so look at this. Look at what is going on here. Let's take the first one is trig function. Trig functions. That is trigonometry function in a situation whereby you have sine, you have sine x or sine theta, and then cos x, and then you have tan x. I will do a video separately, so that not to make a video long, I will establish a proof for each one of these using first principle, how to find the derivative of sine x, cos x, and tan x. I will do separate videos on that one. So here, when we have y is equals to sine x, then dy over dx will be the same thing as cos x. When you have this, okay, let me put it in a tabular form. Let it be on a tabular form. We'll have here y, we'll have here dy over dx. So when you have sine x here, the difference, when you differentiate sine x, it will give us definitely cos x. When you have cos x, when you differentiate cos x, it will give us minus sine x. Then we have tan x. When you differentiate tan x, it will give us sec square x. Now let me just include other one. You recall that if you have x raised to the power of n, it will be nx raised to the power of what? N minus 1. So the same thing, if you have exponential x, it will still be exponential x. If you have log x, it will give us 1 all over x. I am just trying to summarize this table. There are many of them in the table, but I just want to use this one so that we will not be taking much time. But just get the summary of this. Sine x, when you differentiate, is cos x. Cos x, when you differentiate, is minus sine x. Tan x, when you differentiate, it will give us sec square x. Then anything whatsoever that have an exponent of n, or which integer, when you differentiate, this is the general form. And then exponential function, when you differentiate them, they are the same. I will explain that one in detail when I reach to that topic. So, but since we are dealing with a trigonometry function, let's assume that if you are given y is equals to sine open bracket 3x square minus 2 close the bracket, you are given a question in this form and you are asked to find the derivative of this. So this is where function of a function now comes in, because in this question y is a function of the trigonometry, and the trigonometry the sine also is a function of the angle, which is in bracket given to us to be 3x raised to the power of minus 2. So in this case here, to solve this, we will say let u be equals to what is here, which is 3x square minus 2. And then by implication, y will be equals to sine u. So we let what is inside here to be u, so y transform to be sine u. So we solve it and use our formula. So here we have du all over dx will be You differentiate a constant is 0. You differentiate 3x squared is 6x, comma, dy all over du. Remember, this is sine u, which is the same thing as sine x. So this will definitely give us what? Cos u. So you recall the formula that for you to find dy all over dx is equals to dy over dx is equals to, we have dy all over du times du all over dx. So this by implication, dy du is what? Is cos u times du dx is 6x. So this will give us the same thing as 6x cos our u. We say let u be what? 3x. So this will give us 3x square, sorry, 3x square, yes, minus 2, close the bracket. So this is how we solve this one. But you can actually solve this one direct. When you have y is equals to is equals to sine 3x square minus 2 in bracket. So dy all over dx will be equals to, you differentiate what is here and you bring it outside. When we differentiate here, it will give us definitely 6x. Then here, when you differentiate sine is cos, open bracket, then you replace that one again, minus 2, close the bracket. So you can actually solve it using what? Using the direct method without using the formula. That is fun actually. That's lovely. So just look at it. Please make sure you comment if there is anything that you observe. I need your feedback on this one. Thank you so much for watching. Let's see problems that has to do with that has to do with cos, that has to do with also tan. Okay, so what about if I'm given y is equals to cos 3 theta. So let's say I have y equals to cos 3 theta. And then here, you will let u be equals to 3 theta. And then y will be the same thing as cos u. So du over d theta is equals to what? 3. Because now theta is now the independent variable. So definitely dy all over du will give us minus sine u, because when you differentiate cos, it will give us minus sine. So now dy over dx is equals to dy all over du times du. So in this case here, it's not dx, it's d theta, right? Because this is given to us in a form of theta. So this will be dy du, right? So then this one will give us this one will give us du all over what? The theta. Yes, du over the theta. So this is the same thing as minus sine u times, this one will give us what? 3. So this is 3 minus 3 sine, then 3 what? Theta as our final answer. So this is how, if you have to solve for anything that has to do with cos. So can you solve this and show me that if I have y is equals to tan 7x minus 1. So what about if I have something like this? Can you just comment what will be the answer in the comment section? Thank you so much. I would like to see it. So, having done this, I want to combine this one with exponential functions. So, assuming that, let's say, exponential and logarithmic functions. So, logarithmic functions. So, when we have this, I've already given the general form. So since I've already given the general form of that one, we will dive into solving problem. We will still be using either the direct method, or we'll be using the formula of the function of a function, or we have question that can lead us to product rule. So here we will have this to be the same thing as, let's say you have y is equals to, I'm starting with exponential, and then you have exponential x raised to the power of 3. Y is equals to exponential x raised to the power of 3. So for you to solve this one, what we will do is this. We let u be equals to x raised to the power of 3. Then y now will become exponential u. And recall that whenever you differentiate anything in this form, it will still be the same thing. So this one will be du all over dx is equals to, differentiating this one is 3x squared. I've explained how we usually get that. Bring this one down and then reduce this one by 1. So then dy all over du is equals to u exponential u, because when you differentiate exponential, it's still the same thing. So we bring our formula dy all over dx is equals to dy all over du times du all over dx. Excuse me. So this will give us the same thing as dy du is exponential u times du dx is 3x squared. So this will give us the same thing as 3x squared exponential x raised to the power of 3, because u is equals to this. So this will be our what? This will be the solution of this. If we are given anything like this, this is how we will solve this. Alright, so what of if a combination is given and you have y is equals to 2x raised to the power of 2 exponential x squared? So what about if you have something like this? In this case here, we don't use function of a function, because this is a product rule. So since we are still on exponential function, what we will do here is that we will let u to be equals to 2x squared, and then we'll let v to be equals to exponential x squared. So in this case, du all over dx is equals to 4x when you differentiate this, and then dv all over dx will give us, you differentiate x squared is 2x, you bring it down, so 2x, you still repeat this one, this is x squared. Remember, that's an exponential function. So we'll use the formula dy all over dx is equals to u dv over dx plus v du over dx, which is the same thing as, when you replace this one for u, this is what? 2x squared times dv dx. dv dx is 2x exponential x squared plus, the next one is v. Our v is exponential x squared, then times our du dx is 4x. So in that case, when you check, we have exponential, we'll factor it out. So this will give us, this time this will give us 4x raised to the power of 3, and then this is plus 4x in bracket exponential x squared. You can see 4x is common here, so we can bring it out by having 4x in bracket x squared plus 1 close the bracket exponential x squared. So we can stop here. We can either stop here or we stop here, but it doesn't look well whenever there are factors that are the same, so we can't leave it that way. So this is how you solve problems on this that has to do with a product rule on that involves a polynomial and also an exponential function. In that case, you don't use function of a function, instead you use product rule. So let's solve a question that has to do with logarithmic function in order to move ahead. Remember, the topic is exponential functions and logarithmic functions. So assuming that we have a question, y is equals to the log of, I will take this number 1, then we have the log of x raised to the power of 3, and then the next one is that we have y is equals to log of open bracket 3x all over x minus 1 close the bracket. So we have two questions here that has to do with logarithm and logarithmic function. How do we solve this one? So let's go into it. We have, first of all, number one, since y is equals to log x raised to the power of 3, you will let u be equals to x raised to the power of 3, so that du all over dx will give us definitely the same thing as what? To give us the same thing as 3x squared. So since we have this, it means that since we let here be u, it means that our y will be equals to log u, and then dy all over du is equals to 1 all over u. Refer to the other table that I've already given, that when you differentiate logarithm function, you have the inverse of it. So dy all over dx is equals to dy all over du times du all over dx will now be the same thing as du dx is this 1 all over u times du dx is what? Is 3x squared. So by implication, this will be 3x squared all over, that is this time this, our u, which is the denominator, is what? Is x raised to the power of 3. So now let me write it here so that I want to solve the other one there. Dy all over dx will be the same thing as, when you kick out x squared, we kick out x, so we are left with 3 all over x as our final answer. So when you differentiate this one, definitely it will give us this particular one. Yeah. Is there anything that I'm missing here? No, there's nothing that we are missing. We got it correctly. So let's solve this one. The same thing here. If you check, what is in the bracket is a quotient. And since it's a quotient, we have to also solve it either by using both the two methods. But we can simplify it since we know how to use a simple method. So here, let u be equals to 3x all over x minus 1. So then y will be equals to log u. So du all over dx will be equals to, when you differentiate up is 3. Then this will be 3 open bracket x minus 1. We are leaving down. We are now differentiating down here, which is 1 multiplied by up, that is will be 3x times 1 all over x minus 1 in bracket square. Refer to my examples on quotient rule. I use the direct method. So that's how this will give us the same thing as 3x minus 3 minus 3x all over x. Then we have this to be minus 1 raised to the power of 2, so that this will kick out this one. We are left with minus 3 all over x minus 1 all square. So then we have here, let me use this place here, dy all over du will give us 1 all over what? 1 all over u. So by implication here, dy all over dx, I will be using this formula. Is dy over dx is equals to dy du. So dy du here is equals to, where is dy du? Dy du is 1 over what? 1 over u times du dx. Du dx is this one, which is minus 3 all over x minus 1 all in bracket what? All in bracket square. So this will give us 1 all over u is 3x all over x minus 1, then times minus 3 all over, 3x, it's 3. Then you have x minus 1 all in bracket what? Square. Let me bring it up so that we'll not, let me bring it up here. So here, we will have this. Here is a reciprocal. So I can reciprocate this one by having x minus 1 in bracket all over 3x, then multiply by minus 3 all over x minus 1 in bracket what? Square. So by implication, one of this will go with one of this. This will go with this. You are left with minus 1 all over, that is, this will be minus x all over x open bracket 1, this is minus 1. You can leave it this way, or you have this one as minus 1 all over x square, then minus x. Whichever one that you leave it, it is still the same answer. So this is how we solve problems in logarithmic function and trigonometry function, and also exponential function. So I would like to solve problems on implicit functions. This particular aspect of differentiation that we have been doing is called explicit function. So in a situation whereby you are combining the dependent variable and the independent variable in the same place, how do we do that? We call it implicit function. Let's dive into it. Okay, so can we solve problems implicitly? Implicit functions. Implicit functions. So for implicit functions, this is how we do it. This is how we do it. This one. So we'll have this to be, for instance, if you have x squared plus y minus 2xy is equals to 14. So when you have a question like this, you can see the y is not together. But in this case here, since it is implicit function, whenever you differentiate y, you replace it with dy dx. Excuse me. So here, let's solve this one. To solve this one, what happened here is this. Differentiate this is 2x. Differentiate y, it will be plus dy all over dx minus, this is a product rule. So since this is a product rule, you differentiate x is 1. 1 times 2, it will give us what? 2y. You are now leaving x now, you differentiate this one. So this will give us minus 2x dy all over dx. Differentiate this constant, it will give us what? To give us 0. So we can now collect like terms here so that this and this are the same. So we have dy all over dx minus 2x dy all over dx, and then this will be equals to plus 2y minus 2x. So we can factor out dy dx here, which will be 1 minus 2x in bracket dy all over dx is equals to 2 open bracket y minus x close the bracket. So we divide both sides by this so that we have dy all over dx is equals to 2 open bracket y minus x close the bracket all over 1 minus 2x close the bracket as our what? As our final answer whenever we solve this one implicitly. Okay, so let's take another example for implicit function. So, and that one, there are many questions that has to do with proof that we'll be solving on this one. So that one, I'll take it separately. I won't combine it here so that it will not be too long. So here, we have 3x squared y minus 2y squared plus 14x is equals to 17. And we are to find the derivative of this one. And like I said, this is a function of a function. As a result of that, we'll solve it implicitly. So this one is a product. So first of all, differentiate this, which will give us 6x y, because we differentiate x now. So while differentiating, we'll have plus. We are now leaving 3x and differentiate y. When you differentiate y, it will be dy all over dx. Then we go to the next one. Differentiate this one. It will be this one, sorry. We have to find the square y all over dx square, sorry. So in this case here, this will be the same thing as 4y, right? Then dy all over dx. We differentiated one of the x. So this will give us plus differentiating this one to give us 14 equals to differentiating constant, it will give us 0. So having done this one, the next thing that we will do here is this. Since we are asked to find the second derivative, let's just proceed. We will not factor out dy dx. We can decide to factor it out, but when we factor it out, it will lead us to solving problem in quotient rule. So let's do it here straightforward. So we'll differentiate this one again. When you differentiate this one, what will you have? You will have this, first of all, it will be 6y, because when you differentiate x, it will give us 1. 1 times this will give us 6y. We are now leaving this one, so this will be 6x differentiating y, it will give us dy all over dx. We go the next one, plus, in this case here, this is also a function or a product rule. So we differentiate 3x first, which will give us what? 6x. Then we are now having dy all over the x. Then plus, we are now leaving this one, differentiating this one. So this will give us 3 x square, and then the square y all over the x square. Then minus, we'll differentiate this one further, differentiating 4y. Now, when you look at this, then here, when you check here, we have what? We have dy, we have y here, we have dy dx here. So this will give us, when you differentiate 4y, it will give us the same thing as what? Sorry, please, sorry. This one here, it will be the same thing as 4y the square y all over the x square in bracket, since there is minus here. Then the next one, when we differentiate only, when we differentiate this, definitely this one will definitely be the same thing all like this. Sorry, please, there's something I'm missing here. So what we'll do here is this. We'll first of all differentiate this y. So when we differentiate this y here, we will have it as what? We'll have it as 4 dy over the x times dy over the x. Then the next one is that we are leaving this one, which is plus 4y, and then we differentiate this one is what? Is dy all over the x, all this one, this is square and this is square. Okay, so this one here, close the bracket, all equals to 0, because when we differentiate this one, it will give us 0. So we can now look at those ones that are common so that we will add them together. So when you look at this, this is the same. So we have 6 y, and in this plus, this will give us what? Plus 12x dy all over the x. And then the one square, let's tackle that one. This is 3x square, and then the square y all over the x square minus, this is the same. When you time this is square, this one also, so it will give us minus 8. Sorry, we can't sum that one. To give us minus 8 the square y all over the x square, and then minus 4y. Then we have the square y all over the x square, all equals to what? 0. So the question asks us to find the second derivative. So if we are to find the second derivative of this one, we will take this and this to the other side, so that it will give us, we will factor the square y here. We will have 3x square minus 4y minus 8 all in bracket the square y all over the x square is equals to this particular one. It will give us minus open bracket 6, to give us 6y, then plus 12 dy over the x, close the bracket. So by the time that we divide both sides by this, we will have this to be the square y all over the x square will be equals to 1 all over 3, or let me put it this way. It will be 3x square minus 4y minus 8 all in bracket to the power of minus 1 in bracket. There's minus here. That is this minus. We have minus, open bracket, 6y plus 12 dy all over the x, close the bracket. So there are things that are common here, but there's no need for us to factor them. So we stop here. This is where we come to the end of this class. So make sure you subscribe, make sure you share, make sure you comment. I like your feedback. Thank you for